So this video is going to be a demonstration on a haunched mortise and tenon. So the principles are nearly the same for a haunched mortise and tenon as a mortise, as a standard mortise and tenon, where you usually divide by 3, or you go to the width of your chisel. However, a haunched mortise and tenon is designed for a corner of a joint, so i.e. the corner of a door, the corner of a sash window or a box casement window. So for example, if we just said that this was the corner of a door, then that would be the piece of timber for the door. You'd have a groove usually run out in here, and then the haunch would be the haunch there would usually be the size of the groove, if you're machining. So the design behind the haunch is the fact that you've got a full tenon coming through for gluing and strength, but then you've also got a small haunch there, which gives you a bit more material on the end to stop it just falling out. So I'll show you how to draw this. For this one, we'll start 20 millimeters in and 20 millimeters down, and we'll make a cross there. We'll strike a line quite far across on this one because we have to do multiple pieces. So we need to come 32 millimeters this way. And we'll come 150 millimeters down for the joint. And we'll put a mark just there. I'm going to strike a line again, faint, all the way across that board. What I'm going to do then is I'm going to come across 30 millimeters, and this is going to be the start of my corner joint, and then that's going to be 44 millimeters in width that way. Again, I'm going to do all this faint for now, and then we'll add it all back in at a later date. So we're going to come across, because our joint size is 150. So all we're going to do first of all is our boxes, and then we'll add everything in afterwards. So we'll come down 44, we'll create a mark, and I'm going to strike another faint line across the top of that one as well. So there's my one side elevation, there's my front elevation, and now I'm going to do another side elevation on here, and this is going to be at 30 millimeters again off. The reason I've done it 30 is because we need the space coming across this joint, because we have to put in the opposite side elevation. There. So there's our 3. Once we've done that, we'll cast our springing line down for our 45 degrees, and we'll just transfer a line down through there, and then we're going to create this box at the bottom here as well. So we'll do our outside lines first of all, where that meets and where that meets there. Then we're going to take our our horizontal lines off that, and we're going to strike one there, and we're going to strike one along the top. Again, once we've done that, then off our front elevation drawing, we'll just bring down any of our vertical lines which are there. So what you can see now is we've got a side elevation, front elevation, another side, and then the plan view. So with that, what we need to take into consideration now is everything is divided by 3, either divided by 3 or to the nearest chisel size. So for this scenario, we're going to go to the nearest chisel size. So again, like in your mortise and tenon, we're going to come 10 millimeters off the one shoulder, 10 millimeters off the other shoulder, which gives us 12 millimeters tenon. So that's that. And then next, the layout of this joint, where you always use the rationale of divide by 3. So 44 divided by 3 is something like 14.6. So what we're going to do is just round it to 14. We'll round it to 15, okay? So we're going to come in off the end shoulder, 15 millimeters, and we're going to come up off the bottom shoulder, 15 millimeters. That gives us a third and a third. Once we've done our thirds lines, these go in dashed lines then. 1, 2, 3. And this dashed line here can be projected across there, and it can also be projected across here. So on this side elevation, we will do our lines going up, and again all these lines on this elevation are dashed because that shows the joint and the cuts, but it doesn't show it on the face, whereas this side elevation does show it on the face, because as you can see on this joint here, if I turned it, you can actually see the joint, whereas if even though the joint is in there, even though I turn it that way, you can't see the joint, but it is in there. So again, we'll come in 10 millimeters and 10 millimeters, and these are distinct lines, they're not dashed. Again, if we were going to make an actual door and there was a groove inside here, when we rebate this groove out, either by hand or by machine, we would then do this haunch the same size as that groove, and we just run it out on the same size. It just makes life a little bit easier, and then we can go from there. So we've shown our front elevation, and that shows the shape of our tenon. It shows the size of our haunch, and it also shows the cut size of our haunch, but the opposite way around. Now what we need to do is show our mortise size on the plan elevation here. So we've projected our lines, our outside lines down. Now we need to project our tenon lines down, which I will do. And then all our horizontal lines can be met here then. So I'll just draw a line faint for now, and a line faint for now. Then, where we've come down with all our vertical lines off our front elevation drawing, we also need to do it for this tenon mark here, because our tenon only goes through 2/3 there. So that is our mortise size. What I'll do now is draw it in pen, just to show you distinctive lines. again, these haunches in this joint are for structural integrity. It adds structure to the corner of the job, and therefore by adding that little bit in makes the job a lot stronger, and it doesn't just tear out. It doesn't just fall out then, because if you did that, it would effectively just be a mortise and tenon with no side, so it could potentially fall out. Now all the horizontal lines are done, so we'll do all the vertical lines. And again, for this case, we have worked off a 12mm mortise chisel. If you were doing this as a job for a customer, you would work to the size of your mortise chisel on your machines, and they come in all various different sizes. And again, if you are doing it for a customer, you can do it by hand, that's no problem at all. It just takes a lot longer. But again, let's say for argument's sake, you was making kitchen cupboard doors. This kitchen cupboard door, if it's a framed panel, this would be the same cut and the same tenon as you would, and you may have to do 15 doors. Well, each door has 4 joints, so it's an awful lot of joints. Whereas if you do your drawing right and you do it once, then that carries through, and you can make multiple joints repetitively with one drawing. So we'll just put in our 45-degree spring-in line. And I'll do them in dashed lines just to show you. And then each one of those lines there for your tenon will come down and show for your mortise. That's that. Next, what we'll do is put our measurement lines in. There's that one. We'll come over here for the 150. There. We'll also come for a 45. Sorry, the 44mm width. There. That's all our verticals. We just need to add one more, which shows our third by there, and now we can do all our other ones then. So for this top section, I'm just going to do this mortise here, and I'm going to indicate it with 2/3 rather than the actual measurements. But over this side, I'm going to do it with the actual measurements, because we're going to the size of the chisel, not a third. So that's our full width, that's a third, and that there is our all we need to do then is put the bottom one in, to show the length of our joint. There we go. So we can put all our measurements in from there. So the height of our joint is 150 millimeters. The length of our joint is 150 millimeters. The width is 32 millimeters. The thickness is 44. Again, this width is 32. So I didn't really have to put that one in because it's already there. However, I have done it. This one here, you can either put the measurement in, or you can put what it needs to be ratio wise. I'm going to put 1/3, and up this section I'm going to put 2/3. Then over here 10, 12 and 10. So that gives me all the information I need. It shows all sides of the joint. So I'll show you with this temporary piece. So I have, obviously the sizes are slightly different. This one here is my front elevation, and that's what it looks like. If I flip it on its side, that shows the haunch, and it shows the haunch there on show. That's why there's no dashed lines. If I flip the opposite way, that just shows me this length of timber, this end grain, but it shows me that the joint is inside, so that indicates all dashed lines. We'll go back to the start, and if we flip it so it's a plan view, that's the mortise that we're looking at. It doesn't go right the way through to the end, it's a smaller mortise to take into account for that there. So here are the two pieces of timber. If I took that one away, that shows me what that piece of timber is going to be like. If I flip it, it shows me the mortise, the tenon, and that's the shape of the tenon. That's what we want it to look like. Okay. Then if we took the top section and I flipped it, that shows our mortise. But if I flipped it round the other way, it shows the mortise with a little stub on the end.